Hey guys, in this lesson we would understand how to make a graph of the reciprocal of a linear function and what are its key characteristics. Now we know reciprocal of a linear function can be written as 1 over linear expression. To turn this expression or to turn this function into graph, there are two ways to do, and we have to learn both the ways. The first way is we make a graph of the linear function and use its reciprocal characteristics to make the graph of reciprocal linear function. Way 2 is use table of values to make the graph of reciprocal of the linear function. We would go over both of these ways one by one. Let's first go over way 1. Let's say we're given a linear function fx equal to 2x minus 5, and way 1 says we first make a graph of the linear function, then using the characteristics of the linear function, we reciprocate those characteristics and make the graph of its reciprocal function using the reciprocal characteristics. Let's first change this into a graph. Let's say this is our coordinate grid. When we have to turn this linear function into a graph, we start with y-intercept, that is -5. Slope is 2 over 1, so we rise 2, we run 1. This is our second point. We use these 2 points to make a line. This is how the graph of this 2x minus 5 equation looks like. Now we would be writing the characteristics of this original function or this linear function. First is domain and range, because it's a linear function, so domain is xer. Second is range, and that's yer. Second we have to write down as x and y intercepts. Now to find out the x-intercept, we know the function is 2x minus 5. We have to put it equal to 0 and solve for x. So x is 5 over 2, which is 2.5. And we notice here that it crosses through x-axis at approximately 2.5. Therefore, our x-intercept is 2.5. Y-intercept is there in the equation, and because it's 2x minus 5 is the y-intercept that we see here as well. So it is y equal to -5. Next characteristic that we need is the positive and the negative interval. We know positive interval is the entire section in the given graph that is above x-axis. And we notice here that this section of the graph is a positive interval because this is above x-axis. So from 2.5 x value up to the positive infinity, the graph is going to be positive, whereas from negative infinity to positive 2.5, the graph is going to be a negative graph because this section of the graph is all negative. Therefore, the positive interval is from 2.5 to positive infinity, and negative interval of the graph is from negative infinity to 2.5. Next characteristic that we need to make the graph of its reciprocal function is increasing, decreasing intervals. Let's find out what is the increasing interval and what is the decreasing interval in the given graph. We notice that this graph from left to right, that is from bottom to top, this graph is going all the way up. It's never coming down. Since the graph is going all the way up, it is always an increasing graph. So from negative infinity to positive infinity, this graph is always increasing. So the increasing interval is negative infinity to positive infinity. There is no decreasing interval in this graph. So we would be using second, third, and fourth characteristic to find the characteristics of the reciprocal of the given function and use those characteristics to make the graph of its reciprocal. Now let's write down the reciprocal equation. We know reciprocal equation is 1 over 2x minus 5. This is our coordinate grid. Let's use the key characteristics. Always remember, we would write on domain and range after we make a graph. So the first thing we have to remember is that whenever we are making the graph of a reciprocal of a linear function, the x-intercept will become the vertical asymptote of the reciprocal function. Therefore, we would see a vertical asymptote at x equal to 2.5 because we had x-intercept at x equal to 2.5 for the original function. So for the reciprocal function, we would see x equal to 2.5 as the vertical asymptote, and we can mark that on the grid as well. So this is 2.5. We would be making a vertical asymptote here. Make sure to use a ruler in order to get a straight line. Next is y-intercept will get flipped over or will get reciprocated to give the new y-intercept for the reciprocal function. So the y-intercept will give us the y-intercept. However, the value will be flipped. Here the y-intercept is y equal to negative 5. Here y-intercept will be y equal to negative 1 over 5. Negative 1 over 5 means negative 0.2 something. So it's going to be somewhat here. Next is the positive interval of the original function will give us the positive interval of the reciprocal function as well. So even in the reciprocal function, our positive interval is going to be 2.5 to positive infinity, and our negative interval will be negative infinity to 2.5. That means 2.5 to positive infinity, that is on the right side of the vertical asymptote, we would have the positive graph, and on the left side of the vertical asymptote, we would have the negative graph. When we say negative, the graph will lie under x-axis. Next thing that we have to use is the increasing and decreasing intervals. Now always remember, the increasing intervals become decreasing intervals for the reciprocal function. So if the increasing interval was negative infinity to positive infinity, here the decreasing interval will be from negative infinity to positive infinity. And since there was no decreasing interval, here, that is in the reciprocal graph, there will be no increasing interval. This means that the graph will be all the way decreasing in the reciprocal function from negative infinity to positive infinity. Now, before making the graph, one very important thing that we have to mention here is when the numerator degree is less than denominator degree, then we would always have a horizontal asymptote in the reciprocal graph, and the horizontal asymptote would be equal to y equal to 0. How do we know the numerator degree is less than denominator degree? Denominator, we have degree of x is 1. Numerator, we just have a constant. So there is no variable. No variable means x has a power of 0. Therefore, the numerator degree is 1 less than denominator degree. So we would be making our horizontal asymptote. We know asymptotes are imaginary lines on the graph that cannot be trespassed or that cannot be crossed. So this is going to be our horizontal asymptote. Now we would use all of these characteristics, that is all of these green characteristics, to make our graph. Now always remember one more thing, the reciprocal function graphs are always symmetrical graphs. We know the right side of the vertical asymptote is going to be positive, means it's going to be above x-axis or above the horizontal asymptote. And the left side of the graph is going to be below the horizontal asymptote. And since the entire graph is going to be decreasing, how would it look like is, remember it has to pass through this y-intercept as well. So we would keep growing, cross through the y-intercept, and then start bringing the graph down. It is not going to cross the horizontal or vertical asymptote. That's why the graph looks like this. Decreasing means the y values of the graph on the left side should be going down. Now let's talk about the right side of the vertical asymptote, because the graph has to be positive, so it has to be above the horizontal asymptote or the x-axis, and it has to be decreasing. Therefore, the graph has to be positive and decreasing. Whereas on this side, the graph had to be negative and decreasing. So it was drawn under the x-axis and it is going down. Here it is drawn above the x-axis but still going down, since we cannot cross the vertical and horizontal asymptote. Therefore, we just keep going parallel to these imaginary lines and mark arrows there. And this is how we get the graph using the characteristics of the original graph. That was the linear graph. Now, if we want to write down the domain and range, so the domain is going to be XER, where X, we notice, should not be equal to the vertical asymptote because it is not going to touch this line ever. So we would write down X is not equal to 2.5. Now, when we write down the range, it's YER, where Y is not equal to the horizontal asymptote and it's 0 in this case. So we would put not equal to 0 here. This is how we get domain and range when it comes to the reciprocal of linear function graph. Now this was way 1 or method 1 to draw a graph of the reciprocal of a linear function. But there is another way to do so, and we have to learn that way as well. So let's proceed to that way. The second way, or the second method to make the graph of the reciprocal function is, step 1 is to draw horizontal asymptote. Step 2 is draw vertical asymptote. Step 3 is determine and mark the y-intercept. Step 4 is use table of values to determine end behavior near horizontal asymptote. Step 5 is use table of values to determine the end behaviors near vertical asymptote. Step 6 is use all the points to connect and complete the graph. And once we make the graph, then we write down the desired or the key characteristics. Let's say we are asked to make the graph of reciprocal function 1 over x minus 2. Now we know this is a rational function and this is the reciprocal of a linear function because the denominator is a linear function. So step 1 is to draw horizontal asymptote. For that we first need to determine the horizontal asymptote, and because the numerator degree is less than denominator degree, so horizontal asymptote is y equal to 0. Next is to draw vertical asymptote. For that we need to first determine the vertical asymptote. Always remember, to determine the vertical asymptote, we put the denominator equal to 0. So x minus 2 we would put equal to 0, where x is equal to 2. This is going to be our vertical asymptote. To determine the y-intercept, all we have to do is just put x equal to 0 and solve for y. In this case, y is fx. So basically we are solving for fx. Therefore, fx would be equal to 1 over 0 minus 2. 0 minus 2 is negative 2, which is minus 1 over 2. And that's the value of y-intercept. Now we'll first use these 3 steps to mark on the grid, and then we'll go over step 4 and 5. Our horizontal asymptote is y equal to 0. So we'll make a horizontal asymptote line on the x-axis. Vertical asymptote is x equal to 2, which is going to be here. Y-intercept is negative half, which is going to be somewhat here. First 3 steps are done. Now step number 4 is use table of values to determine end behavior near horizontal asymptote. Let's check the horizontal asymptote endpoints first. We know this is our horizontal asymptote. So the end of the horizontal asymptote would be negative infinity on the left side and positive infinity on the right side. Therefore, to check the end behavior near horizontal asymptote, what we would be doing is we would be taking distant x values and use the distant x values both on the left and the right side to make table of values. So the heading is going to be end behavior near horizontal asymptote. We would be making 2 table of values for it. The reason we are making 2 table of values is because we have 2 endpoints near the horizontal asymptote. One is when x approaches negative infinity, and the other is when x approaches positive infinity. For these table of values, just 2 points are good enough. We'll put x here, we'll put fx here, we'll put x here, and we'll put fx here as well. Now the x value that we have to take is, we know we have to go close to negative infinity. So we can take one value as a negative 10 and one value as a negative 100. These are simple values to work with. Similarly, when we are approaching positive infinity, one value we can take is a positive 10 and one value we can take is a positive 100. It's up to you which value you want to take for x, because x is the independent variable. It's just that we want to see what happens to our graph when it is going really far off the vertical asymptote. So we need to take a big number and the small number both on left as well as the right side of the vertical asymptote. We know this is our vertical asymptote, so this is the left side of the vertical asymptote, this is the right side of the vertical asymptote. Now to get the fx value, we know fx is 1 over x minus 2. That was our question function. All we have to do is just sub in the value of x as negative 10, then negative 100, positive 10 and positive 100, and fill these fx values up. So if we put an x as negative 10, we would get 1 over negative 10 minus 2, which is 1 over negative 12. We can change it to decimals, and this gives us negative 0.083 that we can put here. Similarly, we can get the value of f of negative 100, that is 1 over negative 102. That would be equal to negative 0.0098. We can write that here, negative 0.0098. We notice this value has gone really small compared to this one. So let's use these points, negative 10, negative 0.083, and negative 100, negative 0.0098, to mark it on our grid. So negative 10 would be somewhat far off the negative 4. Let's say negative 10 is here, and we notice here this is a negative value, negative 0.083. We know this is going to be smaller than negative 0.5. So we don't have to exactly mark the points because it's not going to be possible. So all we understand from here is that when we are on the left side of the vertical asymptote and x values are negative, the y values are also negative. And when the x values are growing on the negative side, because if we are going from negative 10 to negative 100, the value is going more on the left side, this becomes bigger. Now, how do we see this has become bigger? Because we are comparing negative 0.083 with negative 0.0098. We know that when it comes to negative numbers, smaller the number, bigger is the value of the number. So we can say that the graph is approaching the horizontal asymptote, or it is becoming a bigger value on the left side. Now similarly, we would find out the behavior on the right side. So for that, we would find out what is f of 10, and we know it's 10 minus 2, so it's 1 over 8. That gives us 0.125. When we find out f of 100, it's 1 over 100 minus 2. That is 1 over 98. This gives us 0.01. Here, this is a positive value and this is also a positive value. That means on the right side, we have to be over the x-axis. However, when we go from positive 10x to a positive 100x, the y value is becoming smaller. That means the graph should be a decreasing kind of graph. So these table of values just help us find the end behavior arrows. So this was step number 4. Now we'll proceed to step number 5, and that is use table of values to determine end behavior near vertical asymptote. So the heading for this is end behavior near vertical asymptote. We'll make two tables again. The heading for this table is when x approaches, because we have to reach vertical asymptote now. Let's see where is our vertical asymptote. So our vertical asymptote is at 2. Now we are reaching the vertical asymptote from the left side, as well as we are reaching the vertical asymptote from the right side. So the first heading of the table is x approaches 2 from the left side. Second is x approaches 2 from the right side. Left side is we are going to mark with the small negative sign on top of the number. Right side means we're going to mark a small positive sign on top of the number. Here we would put the x value. Here we would put the y value, that is fx. Here also x value. Here fx. Now for taking the x value approaching the vertical asymptote, we would take one distant value from the vertical asymptote. We can take any x value, so I'm taking negative 10, and one very close value to 2. Let's say 1.9. On the right side, we can take a positive 10 and one very close value, let's say 2.1. So we notice the left side value is 1.9. The right side value here is 2.1. Close to the vertical asymptote. Left side distant value, we can take negative 10. Right side distant value, we can take positive 10. Now, x is an independent variable. You can take any other value apart from negative 10 and positive 10. The reason I have taken these two values is because we have already found out the y value for this. So we can save our time doing this calculation, and we can just put in here directly 0.083. And here we can put in directly 0.125. So all we have to calculate is f of 1.9, which is equal to 1 divided by 1.9 minus 2. That is equal to negative 10. Whereas on the right side, when we solve for f of 2.1, we get 1 over 2.1 minus 2. That is equal to 1 over 0.1. That is a 10. So from here we notice that when we're on the left side of the vertical asymptote, from negative 10 to 1.9, the value becomes a big negative value. Big negative value means the value becomes smaller. Whereas in this case, when we are approaching from the right side, it becomes a bigger value. At 1.9, we have a negative 10. At 2.1, we have a 10. At 1.9, we have a negative 10, which will be going here. And at 2.1, we would have a positive 10 that is going this way. So all we have to do is now just connect the arrows, making sure we cross through the y-intercept. And here also we connect the arrows. And this is how we get the graph using the second way. So all we have to do is just follow these steps. Get the horizontal asymptote, vertical asymptote, then mark the y-intercept, use the table of values to determine end behavior near horizontal asymptote, then use table of values to determine the end behavior near vertical asymptote, and connect everything to make it into a graph. If in case we are asked to write down the key characteristics, we have already noted down the end behaviors. We have already got the x and y intercept, horizontal, vertical asymptote. All we have to worry about is writing increasing, decreasing, or positive, negative interval. So if we want to write down the positive interval, we notice this graph is above x-axis on the right side of the vertical asymptote, that is from 2 to positive infinity. So we just have to mark that. If we have to write down the negative interval, that is on the left side of the vertical asymptote, that is from negative infinity to 2. Then when we talk about the increasing interval, means where is the graph going up? We notice that the graph is always going down, left side or right side. So there is no increasing interval. When it comes to the decreasing interval, it is all the way decreasing from negative infinity to 2 first, and in math is written with this U sign, then it is decreasing from 2 to positive infinity. So this is how we write down increasing, decreasing, and positive, negative intervals for the graph.